In this video we're going to be looking at CC8, which is the acids topic, and it comes up on paper 1 only. So when we're looking at acids, there's 3 acids that you need to know. Okay, you need to know hydrochloric acid, HCl, sulfuric, H2SO4, and nitric, HNO3. You need to know the names, you need to recognize that they're acids, and you need to know the formulas. So what exactly is an acid? Well, if I take HCl as an example, hydrogen chloride is actually a gas. You've got a covalent bond between hydrogen and chlorine, and it counts as being a simple molecule. So it's a gas because there are only weak intermolecular forces. But if you take HCl gas and you bubble it through water, it will dissolve in water. And when it dissolves in water, something quite unusual happens. This covalent bond, which we know as a shared pair of electrons, the covalent bond breaks. And when it breaks, both of the electrons in that bond stay with chlorine, and because chlorine gains 1 electron, it ends up negatively charged. Hydrogen ends up losing an electron, and therefore I can say it's positively charged. And this is how we define acids. We say they're anything that can dissolve in water and split up to give us H+ ions. Opposite of an acid is an alkali. There's only one example you really need to know, sodium hydroxide. Now, it doesn't have to be sodium hydroxide, it could be lithium, it could be potassium. So any of your group 1 metals in front of the word hydroxide, they're called alkalis. So if we look at sodium hydroxide is ionic. I've got a metal and a non-metal, and that means it's solid at room temperature because of the strong electrostatic forces of attraction between those oppositely charged ions. And if I take sodium hydroxide and I dissolve it in water, again, it's going to split up. And when it splits up, I get Na+ and I get OH-. And the OH- ions are what make it an alkali. So by definition, if you want to know what an acid is, okay, it is a substance that produces H+ ions. H+, okay, when dissolved. And because they have to be dissolved to give you the H+ ions, the state symbol for every acid is AQ. Always, always, always. If they're telling you an acid, it must be AQ. Your definition for an alkali then is just a substance that produces OH- ions when dissolved in solution. When dissolved. Alright, when dissolved. And again, because the alkali has to be dissolved to give you OH-, I can say, sorry, I forgot to write the formula here, I can say that the state symbol is always AQ. Now obviously if you had a beaker of an acid and a beaker and an alkali, you can't see the H+ and you can't see the OH-. So if I just gave you an empty beaker, a beaker like that, and I asked you to work out, well, is it an acid or is it an alkali, what would you do? And the answer is you'd have to measure the pH, okay? They've got different pHs. So if it's an acid, it should have a pH less than 7, so anything between 0 and 6. And if it was an alkali, the pH would be greater than 7, anything between 8 and 14. If it was neither an acid or an alkali, if it was something like water, it should come out with a pH of 7, which we say is exactly neutral. So how are you going to measure pH? Hopefully you remember learning about indicators. So there's 3 of them that you need to know on the course. There's litmus, methyl orange, and phenolphthalein. I know that one's a bit awkward, but if you can vaguely remember how to spell it, you'll get your marks. And what indicators do is they change colour depending on whether they're in an acid or an alkali. So litmus is red in an acid, but it goes blue in an alkali. Methyl orange, red in an acid, yellow in an alkali, and then phenolphthalein, colourless, and then pink. Okay, so they'll tell you if it's an acid or they'll tell you if it's an alkali. So they'll be able to answer this question up here. But what they can't do is tell you the exact pH. They won't put a number on it. But there are 2 methods that will actually tell you what the pH is, as well as telling you if it's an acid or an alkali. And one is called a pH meter. Okay, so it's kind of like, it gives you a digital reading, so it's a probe. You put it into your solution and you're going to get a reading here. So it could be 2.34, and if you get a pH of 2.34, you know it's definitely an acid, and you also know the exact pH. All right, so this is called a pH meter. So if I want to measure the pH, I'm going to use a pH meter, and that's the best way to measure pH, because you get a digital reading to 2 decimal places. So I'm just going to write here 2 decimal places, and that makes it the most accurate. Your other option is to use a different indicator, one called universal indicator. And with universal indicator, there's a different color for each pH. So it's not just red for an acid. It's dark red if it was 0. It's lighter red if it's pH 1. It's orange if it's pH 3. It's yellow if it's pH 5. So you have a different color. You have a different color for each pH. So that allows you to see if it's an acid or an alkali, as well as allowing you to see exactly what the pH is. Right, I want you to answer questions 1, 2, and 3 on the next page. Okay, so there's our answers. Iron is H+, for alkalis it's OH-. Make sure you give the charges or you won't get your marks. How can you test a solution? I've said use a pH meter, okay? If it's greater than 7, it's going to be an alkali, and less than 7, it's going to be an acid. You could also say use universal indicator, or you can give me another indicator. I haven't asked you to test pH, I've only asked you to test if it's an acid or an alkali. So any of the indicators will do, but make sure you give your color changes too. Alright, next thing we're going to look at is neutralization. And neutralization is when you take an acid, you react it with a substance called a base, and you form salt and you form water. So water is neutral. We say it has a pH of 7, and because we're making something neutral, we call this a neutralization reaction. So what exactly is a base? Okay, well, you've got 3 different types of bases. You need to be able to recognize them: metal oxide, metal hydroxide, and metal carbonate. So if I take the name of any metal from the periodic table, let's just say calcium, and I put the word calcium in front of oxide, hydroxide, or carbonate, then I have a base. So lithium hydroxide is a base. Magnesium is a metal, in front of the word carbonate is a base. Your actual definition for a base is just a substance that neutralizes an acid, and these guys will all neutralize acids to form salt and water, so we say there are bases. Look at what we did earlier, an alkali. Okay, so an alkali is also a base, but it's a specific type of base. It's a base that dissolves in water. So some bases do not dissolve, but they do neutralize acids, so therefore we say they're bases. If they do dissolve, then we can call them a base, but you can also call them an alkali. So alkalis are bases that dissolve in water, and when they dissolve in water, they're always going to produce OH-. You need to be able to write equations, word equations for these neutralization reactions, alright? So if we have a look at an example, I've taken an acid, hydrochloric acid. Acids are easy to spot because the word acid is in the name. And then I've taken a base, so I've taken the metal calcium and I put it in front of the word oxide, so I know it's a base. Now when you're naming your salt, you always take the metal from the base. So calcium, that's the first word of the salt. The second word of the salt you get from the acid. So if it's chloric, then the ending of the salt is chloride. The extra product is going to be water. If we do another example, nitric acid and magnesium hydroxide. So I've got a metal in front of the word hydroxide, it's a base. I take the first word is going to be the metal from the base. That's magnesium in this case. And the second word comes from the acid. Nitric acid gives you nitrate, and I get water. So chloric goes to chloride, nitric goes to nitrate. The last one I've got calcium carbonate. So calcium is the metal from my base, so that's the first word. And with sulfuric acid, it ends in sulfate. So you need to know those endings, okay? If it's hydrochloric, it ends in chloride. Nitric ends in nitrate. Sulfuric ends in sulfate. Don't forget water. It's always a product. And actually, with this particular reaction, you've got an extra product. You've got what we call a carbonate base. And when you've got a carbonate base, you get an extra product. You get carbon dioxide. And you're going to know it's produced because carbon dioxide is a gas, so you will see bubbles. All right, I want you to have a go at questions 4 down to 9 on this page, please. 4 down to 9. Alright, if we go into the answers, what is a base? It's something that neutralizes an acid. Your 3 different types of bases: metal oxides, metal hydroxides, and metal carbonate. You do need the word metal, I was just being lazy. An alkali is a base that dissolves in water, so I can call it a soluble base. And because it dissolves in water, it produces OH- ions. Type of reaction is just neutralization. Your products are salt and water, but you need to be able to complete the equations. So hydrochloric acid, my salt will end in chloride, the metal in my base is calcium. So calcium chloride is my salt, and then I get water. The next one, magnesium, is my metal, and it ends in sulfate. Because of sulfuric acid, I also produce water. And the last one is a carbonate base, okay? That's why I've got CO2 as well. Sodium is my metal, it ends in nitrate because it's nitric acid, and I do also produce water. Alright, there are 2 core practicals in this topic. The first one is quite straightforward. They want to know how pH changes when you add a base to an acid. So I've got HCl, that's my acid. It's aqueous, so it's here in my little beaker. And I've got calcium hydroxide, so it's a metal in front of the word hydroxide, so that's a base. And as you can see from my little drawing, I'm adding it in spoon by spoon because it is a solid. And the practical is, how do you measure the changes in pH as you add a base to an acid? Okay, well, you need to know what the pH is at the start. Okay, so you measure the pH at the start. Say how you would do that. Okay, the most accurate way is using a pH meter, but universal indicator is also acceptable. So you measure the pH at the start. You'd expect it, because it's an acid, to maybe be around 1. Then you add some base and you stir. You have to say stir. So you add base and you stir. So you stir to make sure that it's evenly mixed. Okay, and then each time you add a spoonful of the base, you measure the pH again. And what you should see, that as you add the base to the acid, because you're neutralizing it, you should end up with a pH of 7 eventually. But then if you keep adding base, then you end up with something that's basic. So it should rise to 8, 9, 10 if you keep adding base, okay? But this is the method. pH at the start, using your pH meter, add your base and you stir, and then get the pH every single time you add base. The other practical they ask you for is how to make a pure salt. All right, so let's just say they wanted you to make calcium chloride, and they asked you to make that salt, and they want you to obtain pure calcium chloride. Now, to make calcium chloride, I'm going to need a base with calcium in it. So calcium hydroxide would be a suitable base, and I need an acid that's going to end in chloride, so I'm going to use hydrochloric acid. And I'm going to add the base to the acid because that's how I make a salt, okay? But when you're doing this, you need to make sure that all of the acid has fully reacted. So you just keep adding base, lots and lots of base, until the base stops dissolving. Okay, so you add the base to the acid until it stops dissolving. When it stops dissolving, that tells you all of the acid has reacted. Because you've just kept adding base, you do have more base in there than you need, but because the base is a solid, you can easily remove it. So if you want to remove a solid from a liquid, if you think back to separating mixtures, you're going to filter to remove. Excess is the word we use for extra. Add base to the acid until it stops dissolving, then you filter to remove all of the excess base. Okay, and at this point, all you're left with is salt and water. But you don't want salt and water, you just want salt. You're going to need to be able to remove the water. Again, we did this in separating mixtures. You are going to use the technique crystallization. Okay, you have to be able to describe that technique. So you're going to say the following. You're going to heat the solution to concentrate. Heat the solution to concentrate, okay? And that just means that you're going to evaporate some of the water, but not all of the water. So you heat the solution to concentrate, and then you leave the salt to dry. So you add your acid and base to make the salt. Because you've added too much base, you filter some of it out. Then you've just got salt and water, and you remove the water using crystallization. Have a go at questions 10 and 11, please. Alright, so first one, measure the pH of the acid at the start, and you're going to do that using a pH meter. Then you're going to add some base and stir. You have to stay stir. It needs to be evenly mixed before you get the pH again. And then every time you add base, you measure the pH. Alright, 3 points, 3 marks. Describe how you could obtain pure dry copper sulfate. Now if they want copper sulfate, you need to use a base with copper in it. I've chosen copper oxide. You could also use copper hydroxide or copper carbonate. To make copper sulfate, you need sulfuric acid. So that's your base and that's your acid, and they'll give you the correct salt. When you're doing this, you keep adding the base to the acid until all of the base has stopped dissolving. This tells you that the acid has fully reacted. You can then get rid of the extra base by filtering. The base is solid, so you can just filter it out. At this point, you've only got salt and water, but you need to separate the water from the salt. So you heat, and the way they phrase it on the mark scheme is to concentrate the solution, and this means you evaporate some of the water. You let the rest of the water evaporate slowly, and then you're going to leave the salt crystals to dry. Okay, so these are two core practicals that they do tend to ask a lot, so definitely worth knowing them.